Hey there, we're back and continuing with this test. Now you can see that what I've set up here is a left-tailed test. I want to know whether the mean for 301 is less than the mean for the 401. And then over here, because this was sample data that I was given, I'm going to have to calculate the x bars. I'm going to have to calculate the s, right, standard deviation, and the n for that matter. Okay, so S would be equal to stdev.s, or if you're working with older Excel, just stdev. Like that. And this is going to be the count on those numbers. You can't just drag this formula because you need it to take all the data. If you just drag, it's going to say 9, but technically this one's 10, right? So there we've got all our numbers. Oh, and I found this with the average. That's x bar. Now, why did I do that? Well, it's because I need the x bar difference right here in order to calculate my test statistic. So the x bar difference is equal to this number minus that number. And I chose that because I chose to make it a left-tailed test, so I'm doing 301 as my first one. If you want to make it a right-tailed test, it would just be the opposite. Then it would be 4483 minus the other one. And then I'm going to need my big square root. Big square root from the test statistic formula, which is equal to SQRT of, and it's S1 squared divided by N1 plus S2 squared divided by N2, which is right there. There we go. So the test statistic, T sub 0, is equal to that x bar difference divided by that square root, which is negative 3.8. So we're probably going to reject because being 3.8 standard deviations away from the mean is kind of a big deal. But we will find out in step 4, which is our classical method and our p-value method. We'll do both. Okay, so classical, we're going to need critical value. Let me label this classical method. So we need the critical value. And this is a left-tailed test, so we're going to need equals t dot inverse, those parentheses. And then I typed alpha up here. And my degrees of freedom, I'm going to go with the smaller of these two. So that's 9, take away 1. There we go. And hopefully you can see from that you're going to reject H naught. Let me put step 5 right here so we can see it right by it. So we reject H naught because T0, which is equal to negative 0.804, is less than T sub alpha, our critical value, which was only negative 1.860. Okay, so that's the classical method. The p-value method. Oh, I forgot one thing. Critical value, we found it that way with the new Excel formula. If you're finding it with the old Excel formula, you're going to have to do a little more work. So it's equal to T inverse, there's the old one. And you have to take this 0.05 and you have to multiply it by 2. Because it needs a T inverse for the old Excel always does two-tailed no matter what. So you have to make it a two-tailed by multiplying your alpha by 2 because you really want 0.05 in your tail still. And then you can take 9, take away 1. I think, yeah, there we go. And then that's positive, notice, because not only does it always take two-tailed inside, but then it always gives you the right positive one on the right side of 0. So you're going to have to do a negative in front of it to make it negative because it's a left-tailed test. Annoying, I know, but that's the way it is. So you're going to have to multiply by 2 to make it two-tailed in the interior, even though it's only a one-tailed test. And then you're going to have to take your degrees of freedom, that's fine. But then you have to put a negative in front of the whole shebang in order to make it the negative value that you were looking for, because it's a left-tailed test. Ugh, annoying. All right, so then the p-value method, I do not have time to do, so I will do it in the next video.